Assalamualaikum and a very good morning. My name is Ashraf Hakimi bin Shamuddin and I'm going to open this group presentation of System Interrupt in Intel Core i9 Architecture for subject CSC 429, Computer Organization and Architecture. So this session shows our group members and our profiles that includes myself, Ashraf Hakimi bin Shamuddin, Muhammad Farha Hakim bin Roslan and Muhammad Adib Hakimi bin Asnan. So this is the poster for our presentation that highlights the main topic for this task, which is system interrupt in Intel Core i9 architecture. In this poster, we have included a total of 8 frames that starts from introduction, organization, steps on how a system executes and interrupts from a device, unicore versus multi-core interrupt handling, interrupt distribution methods, key components in interrupt management, summary as well as reference. Not only that, this poster also includes a total of 2 figures. For the first one, which is the diagram of a system interrupt in Intel Core i9 architecture, and the second one is the flowchart of how a system interrupt works. So I will start off the topic of our presentation with the introduction. So modern computer system requires efficient mechanism for handling asynchronous event to ensure responsiveness, performance, and reliability. One such mechanism is the system interrupts. Interrupts are signals that temporarily halt the normal execution flow of a processor to respond to events such as input-output requests, timer expiration, or hardware failures. In Intel Core i9 architecture, interrupts are handled with advanced techniques optimized for multi-core, multi-threaded execution. These techniques include interrupt affinity, load balancing, advanced programmable interrupt controller APIC enhancement, messaging signals interrupt MSI or MSIX, and visualization support like VTD interrupts remapping. Understanding interrupts handling in Intel Core i9 is essential because it affects real-world performance in operating system, servers, gamings, and other high-demand computing environments. So the next part is, what are system interrupts? So by definition, an interrupt is a signal to the processor indicating an event needing immediate attention. Interrupts consist of 3 different types. The first one, which is hardware interrupts. Second one is software interrupts, and the last one is exceptions. For hardware interrupts, the example for it is an input-output device signaling completion. For software interrupts, which is system calls, and exception is divide by 0. So when an interrupt occurs, the CPU will save the current state, transfer control the interrupt service routine, which is the ISR, executes the ISR, and lastly restore the save state and resume. So we move on to the organization. In multi-core system, interrupt handling is organized using strategies like interrupt affinity, which is binding interrupts to specific cores, load balancing, which is distributing interrupts loads across CPUs, and priority-based scheduling. These approaches ensure efficient distribution, low latency, improved CPU utilization, and responsive system behavior. Advanced features in Intel Core i9 processors, such as hyperthreading, MSI or MSIX, and VTD further enhancing and speed up interrupts handling by enabling faster, more flexible delivery and processing of interrupts.
Okay, so now, every time your computer responds to a mouse click, keyboard press, or network activity, it tends to interrupts. But how exactly does the system handle these signals? So let's walk through the 8 key steps the system follows when it receives an interrupt from a device. Okay, the first step is interrupt triggered. A device like a keyboard or network card sends a signal, known as an interrupt request or IRQ, when it needs the CPU's attention. Okay, step 2, interrupt sent to controller. This IRQ is routed to the Advanced Programmable Interrupt Controller or APIC. This could be the older APIC or the extended version, we call X2 APIC in newer CPUs. Step 3, interrupt classification and routing. the controller decides which CPU core should handle the interrupt based on system rules, current load, and priority. Step 4 is delivery to local controller. The interrupt is then forwarded to local APIC on the chosen core. This component manages interrupt handling at the core level. Step 5 is core receives interrupt. The selected CPU core pauses its current task and prepares to handle the interrupts. Step 6, interrupt service routine, ISR, executes. The core runs a special function, the interrupt service routine, the ISR, that deals with the request. This might involve reading device data using DMA, Direct Memory Access. Step 7, interrupt acknowledgement. Once the ISR finishes, the core sends an end of interrupt EOI signal back to the APIC. Step 8, system resumes normal operation. This is the last one. The CPU core goes back to what it was doing before and like nothing ever happened. Now that we understand the process, let's compare how interrupts are handled in unicore versus multi-core processors. In unicore system, one CPU is responsible for all interrupts. Every IRQ is sent to the same place, which makes things simple, but inefficient under heavy loads. But in multi-core system, like the Intel Core i9, interrupts can be distributed among multiple cores. Here's how it is better. Interrupts are load balanced to avoid bottlenecks. Interrupts affinity allows specific device to talk to specific cores, and multi-threaded environment benefit from parallel ISR handling. So, modern CPUs don't just do things faster, they do them smarter. Efficient interrupt routing is a big part of what makes today's system so responsive.
So hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adil Hakimi, and now I'm going to introduce to you guys what is distribution method for system interrupt in i9 architecture. So first thing first, what is interrupt distribution method? The interrupt distribution method refers to how hardware interrupts are assigned to logical CPU cores or threads in Intel Core i9 CPUs. Performance and responsiveness offered by modern i9 CPUs depends on the effective distribution of interrupts, particularly in multi-core or multi-threaded situations. So next, we move on into the interrupt distribution method. So as you can see in the diagram, it explains how the interrupt distribution method works. It comes from a device, and then you move on into the APIC, and the interrupt being distributed to each logical CPU. So first method is static assignments. Interrupts are distributed to logical CPUs via the local APICs, coordinated by the I/O APIC. And the second one is dynamic load balancing. Distributed the interrupt make sure no core is overloaded. And then the third one is prioritization. DOS or Linux or Windows sets affinity, assigns interrupts to specific cores, prevents one CPU core from being overloaded by all device interrupts. So the third method's prioritization makes the second method, which is dynamic load balancing, works. And the last one is hyperthreading. With simultaneous multi-threading SMT, interrupt distribution algorithms can avoid sending interrupts to hyperthreads of already busy cores to reduce contention. We move on into the key component in system interrupt. As you can see, we have 5 key components which make the system interrupt process becomes efficient. So the first one is Advanced Programmable Interrupt Controller. What is APIC? An interrupt controller that routes interrupts to processor core. Intel i9 supports XAPIC and X2 APIC modes for better scalability and performance. And the second one is local APIC. Each i9 core has its own LAPIC, handling core-specific interrupts such as timers, thermal sensors, and local delivery of messages. The third one is interrupt vector, a unique number assigned to each type of interrupt. The fourth one is MSI or MSIX, a modern interrupt method where devices send an interrupt while writing to a specific memory address, eliminating the need for a dedicated interrupt pin. And the last one is interrupt handler. Code routines written by the OS to handle a specific interrupt. It saves CPU state, handles the interrupt, and resumes its execution. So we've come to the end of our presentation, which is summary. System interrupts in Intel Core i9 CPUs are managed through a combination of hardware and software components to ensure efficient and responsive handling of events like hardware input or system faults. Compared to Unicore, Core i9 features and large case size help manage interrupts with low latency and minimal disruption, even under heavy multitasking or visualization. It ensures real-time responsiveness in high-performance environments. So that's all from us. Thank you for listening to our presentation. Hoping you can understand what is system interrupt in i9 core architecture.